All right, so I'll just slowly go in here and let a couple more people pop in. We are excited tonight to have Reed Lewis, but real quick, I just want to point out that next week we will have, or not week, next month, we will have Joanna Redwine, who's with the Bureau of Reclamation, talk about some really neat trench work that they did. It's actually not really in the Columbia Basin, it's more sort of outside of Portland area in Forest Grove, Oregon, for the Gales Creek Fault. But it's a neat story, and Joanna is just an amazing speaker, so I'm really looking forward to her talk next month as well. For those that are interested as well, we have Emily Cahoon, who got her PhD at PSU, is going to talk for the Ice Age Flood Institute and Eastern Washington University on the 20th of May about some copper-rich plagioclase sunstone inclusions in some of the Columbia Basin or the Columbia River basalts. Sorry, I've been on Zoom all day today. But very excited tonight to have Reed Lewis. I mean, I think everybody on this list, I'm kind of watching it right now, knows Reed, world famous Reed Lewis, master mapper, and all, just knows everything about geology out here. Reed is at the Idaho Geologic Survey. He had graduated actually as undergraduate from U of I, went on to UW for his master's, and then his PhD was at Oregon State University. He's been with the Idaho Geologic Survey since 1998. And I remember the first time I met Reed was he's in charge of the Belt Association, which, a little plug, will have a meeting in 2023 with the Tobacco Root Geologic Society out in Salmon, Idaho. So mark your calendars for the end of July, beginning of August 2023. But the first time, I met Reed, it was out in the Silver Valley, and he kept on talking about his mapping and how he learned from Thor. And I never could figure out why I would ever disagree with Reed, because he's very, very, very good at what he does. But I really don't want to get hit by lightning. And so I would never disagree with Reed whatsoever in the field. He's so good. In fact, even in Spokane, I think in his brain, he can actually spatially envisage everything around him, because he can relate one outcrop in Spokane to outcrops out at 4th of July Pass. I mean, he can relate different outcrops everywhere. And so I'm super excited that Reed is going to talk today about geologic mapping and how that pertains to mineral exploration. And then if you guys could hold questions while we're going through this, you can either type them up in the chat if you can't hold it, or there's a Q&A button as well at the bottom that you can press. And then at the very end, we'll read off the chat questions or the Q&A, or we can, I think, even unmute you if possible, so you could ask questions at the very end. So without further ado, thank you very much, Reed, for coming and talking to us today. I'm looking forward to this so much. Thank you.
All right. Well, thanks a lot, Chad. Appreciate that. As he said, we're going to be talking about geologic mapping in Idaho, and particularly the parts that pertain to the mineral exploration that's going on in the state. There is a tremendous amount of exploration. Actually, it's really picked up the last couple of years statewide. We have lots of companies coming in, Canadian juniors and folks from Australia and all over the place. And this diagram here with those little red dots just shows where some of these exploration sites are. And if you want to learn a little bit more about it, you just go to our homepage on our website. And this is a report that Virginia Gilliman does every year for the state of Idaho, and she has a lot more detail about these various properties and who's working them. The main impetus, obviously, for this is that we have some pretty good precious metal prices, and so most of these exploration sites are gold properties, but certainly not all of them. And here is a display of why folks are coming to Idaho right now. This is gold price for the last 5 years. You can see it was kind of bouncing around $1,200, $1,300 an ounce up until about 2019, and then it started to climb. Actually peaked over 2,000 an ounce. It's dropped down now to about a little less than $1,800 an ounce. But this is the kind of thing that gets people interested in Idaho, because we have a large number of historic properties that have produced gold, and there's certainly more potential in the state as well. As far as the mapping side of things, this map shows coverage of what we consider, halfway decent Idaho Geological Survey maps in a digital format. The areas in blue are areas that we've covered in the last, since the mid 90s or so. The areas that are solid blue, most of those are 1 to 100,000 scale maps. The diagonal blue areas are 1 to 24,000 scale. And then we've got 4 project areas that we're working in right now for state map. And state map has really been the big deal for us. It has been since 93. It was called CoGeoMap back in the 90s. But we've gotten over 5 million from the USGS. Not a lot each year, but the nice thing about it, it's just been steady. So you can sort of plan on it. And every year, then we plug along, add to the existing set of maps. It's a competitive grant. Most of the states put in for it. But we've also, over the years, gotten money from Idaho Transportation Department, Idaho Department of Lands, more recently, the USGS Critical Minerals Program, and I'll talk a little bit more about that today. Midas Gold, now going by the name Perpetua Resources, paid for some mapping up in the Stibnite area, and I'll talk about that. Integra Resources also has paid for some mapping down in Hawaii County in the southwestern part of the state. And then Horse Heaven Syndicate paid for some mapping in the Yellow Pine area recently, and I'll go into more detail about that. But basically, these 4 areas shown with some green, the black outlines with the green, are sort of where we're focused right now. And I'll be mostly talking about the Elk City area and the Salmon project area, because those are 2 that I'm personally involved in. Here's the Salmon project area. We've been in there since 2007, and all these quads here in yellow are basically the ones that we've finished and published on our website since we started. So here's the town of Salmon right here. So we're basically working right up against the Montana border. And in fact, we're working with the Montana Bureau of Mines and Geology, so that when we put out a map, there's actually not a border fault down the border. And so that buys us some positive marks as far as when we put our proposals together. And after we do the 7.5 minute quads, then we come in and we hook a bunch of them together. We put a whole bunch of these together at 1 to 75,000 scale a few years ago. There's also some EdMap projects. Those are shown in green on here, which help cover areas that, we basically, if the students are in there when we're around, we can stop in, see how things are going, give them some pointers, and then that just sort of adds to the knowledge base. And then in the southwestern part of this map, shown here, the Taylor Mountain, Deegan Mountain cobalt quads, shown in kind of light blue color. Those are this new critical minerals program, this thing called Earth MRI, which the USGS started a couple of years ago. And that's been nice because it sort of adds to, we're already in the area, we're down there, and it's basically just a little bit more funding to get more mapping done and more, more digitizing and done in chemistry and things like that. And again, I'll talk a little bit more about that. The Salmon area has been an active area of exploration ever since I've worked in Idaho. It's favorable geology, a lot of it's federal land, and so you've had companies, of course, it oftentimes depends on the price of metals, but they come and they go, but it had a lot of companies come and go, and there's certainly a lot of them in there right now. The couple of things that the 3 main things that they're interested in, shown in red on this diagram, are the cobalt, the rare earth properties. And so those are kind of basically down along the border here, and then they continue up north of Salmon and down along the main Salmon River here. So we have the rare earths, which are definitely a big area of interest right now. The Chinese, of course, controlling that market presently. And then there's been interest also in gold, of course. And the Bear Track mine was a producer in the late 90s up into the early 2000s. And now there's several companies looking across this entire area for gold. but I'm going to just be talking mostly about the bear track. And the bear track's on a north-south structure here, which we call the Coiner Fault. The name comes from the Coiner Ranch, which was right down in here. It's a north-south structure that we've traced on south down into this Iron Creek area. And this is a little different than the past mapping, which showed the bear track mine actually being on a northeast structure, which was called the Panther Creek Fault. We haven't found much evidence of faulting along Panther Creek, and we think instead the bear track is on a bend right here on this north-south Coiner structure. Here's a shot of on the left here of the South Pit at bear track. So like I said, this thing operated through the 90s, late 90s, and then basically when they stopped mining, the South Pit filled up with water partly, and that's what you're seeing here. The fault is really well exposed at the north end of the pit, and I show it here on this blue line right here, and on the map there's the pit right here shown in blue, and here's this what a lot of people call the Panther Creek Fault. Again, we're calling it the Coiner Fault. Comes down through here. Panther Creek is basically off this direction, and we don't think there's much faulting headed out this way, but this is a really important structure. Probably had early right lateral motion on it, and then in the Eocene was a dip slip down on the west fault. This map is we haven't published this yet, but this is the kind of thing we're doing right now for 1 to 24,000 scale mapping, and in this case, it happens to be in an area with the mining interest. Shown on the left here is some of the myelinite that comes out of this Panther Creek Fault. So you can see that there's been some, pretty impressive deformation. This was actually a Precambrian granite originally, and now is basically just smeared out and unrecognizable as a granite. It's a really nice myelinite. This is probably formed during the early strike slip faulting. And then on the right, you see the existing fault, the existing map when we started in this area. This is the 2003 USGS Salmon National Forest map. It's been a tremendous help. I've got a totally beat up copy of this, all duct taped back together again, and coffee stains and such on it. It's been very, very helpful map. However, there's definitely some things when you go in and start looking a little more closely that need to be modified. So the bear track mine's right up in here. That fault I'm talking about is right in through here. And rather than extending down here, down Panther Creek, where it has been mapped, we believe that the main structure actually continues to the south here and connects either into this fault or possibly into that fault. This is an area we're going to work in next summer, see if we can't figure out what direction it goes. But basically, my feeling is that these north-south structures are really underexplored, and people have sort of been focusing on this northeast grain, and I think that's at least up in the area west of Salmon. That's probably not necessarily the best idea. You can see also, basically, the USGS map doesn't show any offsets across, on the Panther Creek Fault for any of the rock units, which is also a little bit suspicious. The Trans-Challis fault zone was a big deal back in 1990. There was a TRGS meeting in Salmon, and the bear track mine had just been discovered. People were getting rolling on that, and then Thor Kilsgaard is the one that actually put together this guy I worked for, a USGS guy, put this figure together, and he kind of cherry picked. I hate to say it, Thor, but he kind of cherry picked some of the faulting in this area, and he really doesn't show any of these north-south structures. And I will be the first to admit there's lots of northeast stuff going on, northeast Trinity and Grabens and so on and so forth. But I'm not sure that they are necessarily the best gold target. And at least at bear track, the mineralization is Cretaceous. And so it could be that this is just an overprint. This northeast structure is just an overprint on the north-south Cretaceous system. And so this is just dumped off of our website. If you just just look for all the properties where gold is mentioned. A lot of these are just little tiny prospects; they're not necessarily mines. But basically, these are all gold. Gold is reported at all of these, and you can see down around Boise that okay, there's I would argue there's definitely some northeast trends down here, and heading up into the Chalice area. But when there's a lot of other places here where there's really not this necessarily a northeast trend, and I think this more north-south stuff that's going on in this area is potentially more important. Of course, a lot of this out here in this wilderness, but not the case when you get up to Elk City. The other thing that we're finding in our mapping around Bear Track is that there's actually a lot of tertiary sediments out there. And a lot of these right on the Bear Track area were called glacial deposits because these really big boulders, really coarse sediments, and unconsolidated for the most part. And there's two different ages shown in this kind of dark brown are some what we think are Eocene sediments. And then those are overlapped and overlain by these, what we believe are Oligocene sediments. We've got a uranium lead date off of tuff on top of these sediments from some drill core that gives us the Eocene age. And then we've got down in this, there's some just some ash basically in these Eocene sediments down here. And again, we've got a uranium lead age. But the early story here is, I think, is slippage on this Coiner Fault down to the west. So there's actually a pretty impressive Eocene basin on the west side of this fault. But on the east side, it's not very, the tertiary is not very thick. So here's a cross section, west to east, showing that. So here's the Coiner Fault right here. You've dropped a pretty impressive basin of Eocene. This TSO is the Eocene over here, and then you've got this overlapping larger area of Oligocene sediments. And we have control. Revival Gold has been just fantastic. They're the ones that have gone back into the Bear Track and are doing exploration there. And they gave us, they let us have access to their core, and that's how we were able to really piece together this story, this younger story. These are not mineralized rocks. These Eocene sediments are not mineralized; they're post-mineral. But as far as figuring out the local tectonics, it's been very helpful. So here's what some of the core looks like. Let us take a look at. Down in the bottom of this hole, right over here, you can see some, really coarse conglomeratic material. And actually, some of these boulders are huge. They almost fill the whole core box up. So these guys drilling's a real joy through some of this. And then other places, there's a whole lot of clay, like up in here, some of these weathered tuffs. And so again, the drilling has been difficult through some of this. But the neat thing is that there was this biotite tuff in here that we were able to get zircons out of, and these were dated down at Boise State, 48.3 million. So all this coarse material below that is older than 48. Certainly not glacial deposits, and definitely fits well into sort of the Chalice time frame. And these sediments are all over the place in that area, and some are really high. This is the Haiti mine. This is hundreds and hundreds of feet. I don't know exactly what it is, maybe 600-700 feet above the modern drainage. This is just west of Bear Track in the Arnett Creek drainage. And these were plastered. How these guys got water to these things, it couldn't have been a very long season where they were plastering these, because there's really no drainage up this high. They had to dig ditches for miles to bring water around the side of the hill to this locality. But so some of these tertiary sediments actually have gold in them. We see that elsewhere in Idaho. We see it at Elk City, Boise Basin, and Warren, up at Murray, and so I think it's important to be looking at these as these older deposits, trying to understand the old drainages, trying to figure out, okay, there's gold in here, where did it come from? Which direction was the old drainage, way back when, the tertiary, which way was it going? Although in this case, there's bedrock here that actually is mineralized, that has gold in it. So it doesn't have to, in this case, it didn't have to come particularly far. Then the other part of the Salmon area story is the copper and the cobalt. This is what's called the Idaho Cobalt Belt, and it runs from up around, this is the old, relatively new discovery, late 90s, called the RAM, and the old Blackbird mining area was right down in here. This is the Black Pine mine, which was a copper producer a long time ago. And then this is the Iron Creek deposit, which is under exploration right now. This comes from Iron Creek. This sample right here is a polished sample, and you can see some very, very fine, shiny material here. That's actually extremely fine-grained pyrite that's got cobalt in it, and then some of it has recrystallized. So these coarser things right here, those are pyrites, and then there's sort of a fine-grained pyrite in this. Otherwise, it started out as a siltstone, but there's a lot of disseminated pyrite in here, and some of this very fine laminations, very fine-grained material in here. Some workers have thought that this was a synsedimentary deposit, so this would be the same age as the belt super, young end of the belt supergroup. So these could be something on the order of, just a shade younger than, say, 1.4 billion years old. That's one thing we're trying to get a better handle on is any of this synsedimentary, and if so, how much of it is. And clearly, some of it is later. This is a vein that was drilled. This is the Black Pine mine, and Jervois, Australian company, was kind enough to let us take a look at this core. So a lot of this material, there's a lot of remobilization of the copper and the cobalt. In this case, there's a lot of copper, chalcopyrite in here. I'm not quite sure how much cobalt there is, but clearly been remobilized into veins. Then this is the host for a lot of these deposits, these copper cobalt deposits. This is the banded siltite member of the Apple Creek Formation, and anybody who's worked in northern Idaho, worked in the Wallace Formation, the middle part of the Wallace, you're going to go, oh yeah, it's Wallace. And Don Winston, this is Don's walking stick right here, will tell you that's exactly what it is. It's Wallace. We think it's actually younger than the Wallace, but it's basically the same sedimentary environment. And you get these really nice graded beds and these little, what we call tigmatically folded, these little cracks. They're really not mud cracks. We don't see mud chips in here, but they're definitely silt that fills down into an opening in the finer finer stuff, the argillites. And just below this, this Apple Creek, this banded siltite member is what they call the coarse siltite. USGS called the coarse siltite, and that thing is just loaded with magnetite. And some of the magnetite people have thought was banded iron formation. I don't know if that's the case. Some people think that, oh no, it's just there's some buried mafic intrusions underneath all of this. And again, that's an area of research that we're just getting started on. What's going to help a lot with that is the USGS has this. So this is Earth MRI is their critical minerals deal that's been going a couple of years now, and we've gotten funding for 2 more years to work out in here. But the neat thing is the USGS is going to be paying for a big aeromag survey, mag and radiometric survey, and then a couple companies have also chipped in some money to make it a little bit bigger area. And we're hoping this gets flown this fall sometime. It's going to be 200-meter spacing. It's going to be much more detailed mag than we have at the moment, which is shown on here. Here's a mag high kind of coming down through here. This is that lower part of the Apple Creek Formation I was talking about. And so not all of these magnetic highs are necessarily intrusions. Now, this might be intrusion related up in here, but I think this is sediment related. And I think some of these might be basement rocks over there. So I think that the key is to get a, you got to know, you can't just assume it's just some kind of, mystery buried intrusion. And so we've been collecting magnetic susceptibility data from outcrops to kind of sort that out. And lastly, another nice thing about this is the USGS is running a bunch of geochem samples for me. I haven't gotten the results back, but normally we don't have that in our budget. So it's kind of nice to basically say, hey, let's just, what's going on in this rock? Let's check the geochemistry. You can't really see it in here. There's kind of a purplish pink color, which at the time I thought, well, maybe that's cobalt bloom. I don't know. It doesn't quite look like it, but I had some X-ray work done. It turns out it was monazite, just pure monazite on a fracture, which is a cerium. It's a rare earth bearing mineral. And it's probably, it's not necessarily going to make a mine, but the fact that, we do have these rare earth deposits out in this area, it's going to be, I'm going to be curious to see what sort of values we get out of some of these rocks. The last thing here too, I want to make a little pitch for our website. This is our interactive map. This happens to be the Mines app. So you can click on any of these things up here, geology, oil and gas, whatever. But if you click on the mines, it'll give you all these little dots for all over Idaho. Those are mines or prospects. And then you can actually do a search on commodity. This is a cobalt search. So here's the Ram deposit up in here. Here's Iron Creek. But basically all those green things are properties where there's, cobalt is reported. And then we have over 15,000 documents now tied in, PDFs that you can download off of this site. So we have all the old Noranda work up here in the Blackbird, for example, that are free downloads. You just click on it, download the PDF. Okay, Elk City is the next one that I've worked on, and Rusty Fiore, who's a relatively new hire at the IGS, has been with us for a year. He's taking the lead on this, but this is an area that I worked with a pretty large IGS crew back in 1989, right around Elk City. And the key thing, one of the things that we are interested in here is these are all, again, gold. All these things are properties with gold reported. And there's quite a bit of exploration activity going on right now in this Elk City area. So we're basically coming back in and refining the work that we did in 89. In 89, we recognized this Ore Grande shear zone. It's actually a pretty broad zone in between these two faults. But there's also lots of other things going on that we really haven't quite figured out. So that's the main push in here. We've also done a series of quads over here in the west. This Harpster just this last summer. This is the suture zone. So this is the boundary between sort of continental Precambrian North America to the east here, and then these are all Mesozoic accreted terrains off to the west. So that's kind of a critical quad as well, because that's basically suture zone goes right through the Harpster. This is what the Ore Grande shear zone looks like in a lot of places, just totally beat up rock. There's sort of an older, again, just very much like what we see over around Salmon. You got an older, more myelinitic kind of fabric, and then some later brittle stuff. And then there's gold mineralization associated with that, oftentimes not right on the zone, and oftentimes the veins are actually a pretty high angle to the zone off to the either east-west or northeast-southwest. But they're all pretty close to that structure. And there's also some Forest Service LiDAR, which is always fun. And we're getting lots and lots more LiDAR for Idaho, which is great. And here's Elk City, and just west of Elk City, this is where the eastern arm of the Ore Grande shear zone comes up here. This is a Buffalo Gulch fault. And you can see on this thing, this has got some really recent motion on it, probably post-Miocene. Who knows? I mean, this thing could break again tomorrow. Which was pretty surprising to see. And if anybody's been up there, it's all covered with wood, trees and stuff. So it's kind of hard to really see what's going on. So the LiDAR is a big help there. And now I want to switch down to the Stibnite project. This is an area that I worked in 2000, actually started 2010 or so off to the north, and then right in the Stibnite area, 2012 to 2014. Just a little snippet of our map that we published for this area. This was the main point of us being in there. We're kind of doing a sort of a district-wide map. We didn't really spend a tremendous amount of time. This is the Yellow Pine Pit here. We didn't spend a huge amount of time there or down here at the Meadow Creek Mine. The companies who've been there, know a whole lot more about that kind of detail, particularly with the core data that they have. We were just mainly looking at the kind of the regional story, delineating the faults, working on the stratigraphy. Turns out that there's this unit right here is actually Ordovician, and we were able to figure that out using detrital zircon works. There've been arguments for a long time whether there were, are these belt rocks, are these younger than belt rocks? And it turns out, yeah, they're decidedly younger than the belt supergroup, and they come up into the Ordovician. And so Midas paid us to not only map, but they also paid for some zircon analyses, and this basically graph shows you the number of grains at a given age. Okay, so there's a bunch of grains in here at about 1700. So this is an MA, so 1.7 billion year old zircons, some even older zircons, but critically in this sample, there's a whole bunch of 500 million year old zircons. So you're not going to get 500 million year old zircons in the belt, which is 1.4 billion. So this is clearly a pretty relatively young sedimentary rock. All the quartzites out there, they look a lot alike. They're just kind of clean, unlike the belt supergroup. They're pretty clean, and unfortunately, though, there are lots of different ages, even though they all kind of some of the marble Missouri Ridge. So this is just northwest of Stibnite a little ways. And it turns out that that's either Cambrian or Ordovician. And then the quartzite that I pointed out earlier, that's near Cinnabar Peak. That's the stuff that's the Ordovician. And it is essentially the Kinnickinnic formation, which is found down near Clayton in central Idaho. The mineralization is largely necessarily along these big north-south structures, but near them. This is the old Meadow Creek mine, and the Hanger Flats deposit is down here. Gold, historic, quite a bit of antimony and tungsten as well, but gold is what really is keeping people in the area. And so here comes the Meadow Creek Fault, and it has this bend in it, and then it kind of heads off into what we were calling the dismembered zone. And then there's another structure over here that goes up to the West End pit. This is the West End Fault. So you're getting this mineralization, close to these big through-going regional structures. And I think in this case, this bend is important. I think this again had some right lateral strike slip motion on it, just like you saw at Bear Track. And I think wherever there's a bend is where the rocks really get beat up, and you can have fluids coming up through those corner zones. So in my view anyway, this is very similar to what's going on at the Bear Track. And this is just a shot of what the Meadow Creek fault zone looks like right down in the Yellow Pine pits, and pretty beat up rock. Way back in the 30s, they started to piece this story together and thought that there was right lateral kinematics, and I would agree. So after Stibnite moved west into the Yellow Pine Quadrangle, this was in 2019, 2020. I should say that a lot of this mapping is done by the Stewart clan, Dave Stewart and his nephew Eric Stewart, real mountain goats. A lot of the stuff in this area in the Stibnite Quad had 4,000 feet of relief, and they were up there climbing around like goats, and a lot of the mapping was done by them. Also talked Dave into carrying a magnetic susceptibility meter around in the Yellow Pine Quad, and then he continued to work on the stratigraphy. And in this case, we had money from a group, three guys who went by the name of the Horse Heaven Syndicate. We're paying for this mapping. This is just a simplified, I shouldn't say simplified. This is the northwest corner of the Yellow Pine Quad. And the Johnson Creek Shear Zone, north-south shear zone, has been known for quite some time now. It's roughly, a mile and a half or so wide. But what we discovered, there was a ductile zone in the west, and then a brittle silicified zone that is where a lot of the exploration for both tungsten and gold and antimony has taken place. And again, it's similar to Stibnite in that you have this big sort of north-south structure, and the kinematics that Eric Stewart was able to get off that Johnson Creek shear zone and the ductile part, again, showed right lateral strike slip motion. We hope to get this thing published here. It's done, been turned in, and hopefully get this out on our website this year. We were also interested in the magnetite story here because there was thought that there was a buried pluton off in the eastern part of the area, high magnetite. Turns out that magnetite is real common in one of the plutons that's exposed at the surface. It's Cretaceous. Here's what the Johnson Creek shear zone looks like on the left photo. Just some of the granite. This is Idaho batholith material. And Eric has outlined a couple little some little sheared out quartz there that you see in this western, more ductily deformed part. And then this on the right is the brittle deformation you see in the silicified zone. This was actually recognized by Ben Leonard. USGS worked in there back in the 50s and 60s and 70s, and he had I got a hold of his old field maps and his notebooks, and he was the one that really defined this brittle silicified zone. And there's been quite a number of people poking around and some drilling that was done in this zone, but so far nothing's come of it. Like I said, I had Dave back in this little guy around. This is a little magnetic susceptibility meter. It gives you some numbers for, fundamentally it's basically how much magnetite's in the rock. And it turns out that one of the early metaluminous plutons in this area, it's got hornblende in it places, also has quite a bit of magnetite in it, as do some of these, more felsic, some of these aplytic or leucocratic granites also have these big magnetite clots. So when you do these areas, you put a little bit of the story together at Elk City, and then you put a little bit of the story together, at Stibnite. And there was an EDMAP down here in the Clayton area, an ISU work with some detrital zircon work, and you basically start to piece together a regional picture. And it turns out that there's this gray here is a bunch of Neoproterozoic to Ordovician sedimentary rocks. It's mostly Idaho batholith, of course, but it basically goes all the way from the Clayton area up to Stibnite, Edwardsburg, around the bend here, Grangeville, and actually comes right through Moscow. The ridge right behind Moscow here, Paradise Ridge, has got some of these same rocks on it. And then to the northeast of that belt is all belt rock. So all of this area in the lighter gray and here is all Mesoproterozoic. So basically, in this part of Idaho, you're going up section. So you're going from the Mesoproterozoic on up into the Neoproterozoic and even into the Paleozoic as you can go to the southwest. And then you can see that there's a lot of section missing as you come in around this bend of the suture zone. So this is a rift sequence. Back 20, 30 years ago, folks said, oh no, this is all gone here. We don't have any other rift sequence. Really end of the Neoproterozoic, really Paleozoic rift sequence. And as it turns out, it is present, just not a lot of it because of all the granitic intrusions. Then finally, this is a mapping project I don't really have anything to do with, but IGS does. And Virginia Gillerman with the IGS in Boise, as well as Dennis Feeney here in Moscow, and Andrew Canada, who worked for us out there, have put together some maps. It was funded by Integra Resources. They're doing two 1 to 24,000 scale quads, the Delamar and Swisher. They're nearing completion. This is the youngest gold silver mineralization in Idaho. This is somewhere in the vicinity of 16 million year old mineralization. So pretty young stuff, shallow, epithermal sort of things. This is just a shot of the. This is not a finished map, but this is kind of where they stand right now. And here's the Delamar mine where these guys are drilling, and then they got quite a bit of interest off to the east of here, closer to Silver City, but also they were interested in some of the structures and the alteration and rock units northwest of the Delamar. And one of the really cool things about this project is that they've been able to get a bunch of high precision uranium lead ages on the various rhyolite units that are out there, which I think is going to really help tie all that stratigraphy together. So in conclusion, I would argue that geologic mapping is useful in locating structures, favorable rock types, for exploration people who oftentimes don't have the luxury of covering a big enough area to really see what's going on. I think the state geological surveys, they fill a niche here. I think that's one reason why State Map has been such a successful program nationwide. USGS mapping, there's USGS folks around, but they're really not doing the kind of mapping that they did, back decades ago. And so I think the state surveys are sort of stepping up and filling that role. I anticipate that we're going to continue doing 1 to 24,000 scale mapping and leaving the details to the industry. And I would also say that we're going to continue to seek collaboration and funding from industry. It's certainly been very helpful to get that funding, but also just guys sharing, letting you take a look at the core. I mean, I think the companies these days are much more open, and it's very helpful for us to have that sort of access. And then in conclusion, I just want to thank all these folks. They're the industry, largely industry people that I've either worked with or who let me have a look at the core or what have you. So it's been great. It really helps us understand what's going on, and I think it also is a two-way street. I think that we give them some information that is also helpful on their end. And then I'm also ending with the USGS state map and these Earth MRI programs. These have been critical for the state of Idaho to get to where we're at right now. And with that, here's a shot of a drill rig last October, Idaho champion in the Elk City area, and we got a lot of rigs going in Idaho, gearing up again this spring. And I think you're going to see another pretty active summer. So with that, I'll end and take questions.
Very nice talk, Reed. Thank you so much. So yeah, we had a couple pop up in the Q&A, and folks please feel free to ask some questions. The first one is, can you kind of describe your experience with EDMAP, the USGS?
Yeah. So we don't really, you have to get a sort of a raw letter from the state survey to do EDMAP. And we might kind of generally, point people, sort of in a general direction, but we don't really have a lot of, saying in that or where people go. Anybody who's going to do geology in Idaho, basically, we're all behind it. We do publish EDMAP maps, basically PDFs we'll post on our website. Sometimes it takes a while because we're really not funded to do that through the state map, but we will eventually, the better maps anyway, that we'll get those out there. So we don't have a real, and I might stop by, say, like the guy working down by Clayton, I stopped by because I was working in the area and spend a day or half a day or something with the students. But beyond that, we don't have we don't have any say in who gets funded or doesn't get funded.
Fair enough. Chris, who you just said thank you to, Dial, is the USGS consider flying radiometrics along with the MAG for the Earth MRI?
Yes, they are. It's pretty much, I think that's been kind of standard, and they've done about 4 or 5 of these now across the country. And if anybody's interested, just send me an email and I can send you a link to those products that they've put out so far.
All right, and Andrew from the Washington Geologic Survey. Great talk, Reed. Thanks for the great map. What with the growth strata and the tertiary seds at Bear Track, how old is the Coiner Fault? In other words, what is the fault's temporal relation to mineralization?
I think that well, it's hard to say. I mean, it could be way back into the Precambrian, but I think it had, it had a fair amount of Cretaceous motion on it. And I think that's when the mineralization took place. Now, I forgot to mention it, but just to the west of that is at that Haiti mine, those are Ordovician plutons. And so I kind of wonder if some of that gold might have been introduced into that area actually in this, there's cyanites out there and so on. And I think there could have been some gold even coming in the Ordovician. But I think for sure in the Cretaceous, is when the big story was for the right lateral motion. And then I would argue that it's been dip slip pretty much ever since. So like, the Eocene story was probably dip slip. It may have continued moving into the Ordovician, but it's the Ordovician, excuse me, not the Ordovician, Oligocene. The Oligocene sediments are basically silt, lots and lots of silt and nothing coarse at all. And sort of get the sense that the whole thing was kind of dying by that time, in contrast to the Eocene stuff, which was really super coarse, material dropping off it had to be almost a cliff face there.
Fair enough. Good. Ann Johnson had asked earlier, what's available from the Geologic Survey from Gold Bug Ridge?
So Gold Bug is, if I'm thinking of the same Gold Bug, that's where the hot springs, is that the one, the hot spring, Gold Bug hot springs?
That could be.
If that's true, then we have a EDMAP by Hansen, Connor Hansen. So if you just type in Hansen at the top of our website, you'll get a geologic map that covers, pretty sure covers Gold Bug. The Gold Bug hot springs anyway.
All right, and then the big guns from Hecla here, Ben Henderson was asked, he said, great talk. What are your thoughts on mapping kinematic indicators? Are there ones that you think are often interpreted incorrectly or tend to be mistaken, especially slicken lines, steps? You had some beautiful porphyro clasts in there, which we just learned about in Geology 431. Thank you, Reed.
Well, I think a lot depends on what the rock, started as. I first started looking at kinematic indicators when I was working in the Idaho batholith, particularly the Bitterroot lobe and the Bitterroot myelinite and all that sort of stuff. And I was really super confident that I could see, SC surfaces and stuff like that. And as the years go by, I seem to be less and less confident, maybe because I'm working in finer and finer grain rocks. If you're in the, in the belt, and you're starting out with a fine grain quartzite, and then you start to shear it, I think it's a lot trickier. And we oftentimes don't take the time to get thin sections and oriented samples that we probably should be doing. But I think in those cases, it's pretty tricky to get the kinematics. So I think it just depends in part anyway on what kind of rock you started with.
Okay, and I think the Buddingtons raised their hands real quick. So Andy, if you're there, I'm going to ask you to talk. Unless he stepped away for probably a cup of tea, I'm sure.
Yeah, I'm sure. Yeah. I don't want to talk to Andy anyway.
Okay. Maybe not. Oh. Somebody else had their hand raised. No, good. Yeah, Emily. Emily Cahoon was just asking, thank you so much, Reed. Awesome talk. Think about the age and spatial extent of some of the mineralized zones. Would you anticipate that any of the regions would extend west over the SRSC?
Well, there's, I think it's a different system. There's certainly gold, once, like around Riggins and once you get into Western Idaho, certainly a lot of copper, but there's also gold in the accreted terrains. I think it's just maybe a different story. And unfortunately, I think a lot of those, what may have been deposits to start with, might have gotten smeared out. But I wouldn't count them out. I mean, I think that there's definitely some potential off to the west. Of course, a lot of that would be in the, now would be in the Hells Canyon National Recreation Area and things like that. But there's certainly, but I don't think it's the same story. I think my guess would be it would be older mineralization, maybe in some cases as old as Permian.
Very cool. I can never get that space bar to work for my unmuting on Zoom. Sometimes it only works if I'm tuning my guitar during a meeting, I think. Oh, here we go. Great talk, read by Teresa. Okay. Rich Gashnag. Hey, Rich. Is there anything new with the CUMO site, the CUMO site?
Not that I'm aware of, but I think Jenna Gillerman would probably know better than I do. That's a huge deposit, but I think I don't think there's been a lot of action there in the last 4 or 5 years, but I haven't been there. I actually split core there when I was an undergrad with a job, but I haven't really kept up with that one.
Fair enough. So I like these questions popping in here. So there's a follow-up from Andrew. He's talking about the tertiary seds, the growth seds that you talked about a little bit earlier. What do you think the driving force is for the dip-slip stress regime in the Eocene and Oligocene? Just a little bit more maybe about the central Idaho tectonics.
Yeah, so I think in some cases when you look at the dike orientations in the Eocene, they tend to be north-northeast. But I think if there was older existing structures there, like these what I think are big strike slip faults that are Cretaceous or older, I think when you start to relax things, it's kind of like close enough. And so they're dropping down as grabens, even though it's not quite oriented in that sort of northeast or north-northeast orientation. But it's basically, there's a lot of extension. I think that just you go from the compression in the Cretaceous, and then things start extending probably in the Paleocene and certainly by Eocene time. And if stuff is kind of north-south to north-northeast, I think you're going to get tip-slip motion.
Just after some of Brian White's talks, are some of the older faults generally just straight north-south? Do those extend down? I'm not sure how far.
Well, yeah. So no, he's really big on the north-south thing, up in the Coeur d'Alene and north of the Coeur d'Alene district, and dating from back in the belt days. So, we may have had that structural grain from the get-go. I'm not quite sure about that, but certainly possible.
Fair enough. Cool. I think those are some great questions and great answers where you didn't even take a second to think about it. You just knew it. It's good. So I think we can just say thank you and go enjoy the fact that there's still a little sun outside already at 6:50 Pacific Standard Time. It's great. Everybody's saying thank you. Yeah, that was great, Reed. Thank you so much.
All right.
I'll try and get this up.
That sounds good.
See you next month.
Okay, good enough. Cheers.
All right. Cheers.